So today and for a few days we're gonna stay with surface area, but we're gonna move on to shapes that don't have anything to do with circles. Okay, so you can find lots of things in your house that are gonna resemble the shape we're doing next, which is called a rectangular prism. Okay, so rectangular, this is like a box of Kleenex I found. This is a perfect rectangular prism. It's three-dimensional. Prisms are three-dimensional. And it's a prism if all the heights are the same, like this. Okay, so see how this cone peaks at the top? That would not be considered a prism. Okay, but a cylinder would be a kind of a variation of a prism because the top and the bottom are the same. So the top is a rectangle, the bottom is a rectangle, and has the same height everywhere. So that's called a prism. And the reason it's called a rectangular prism is because the bottom is a rectangle. So you can have a triangle prism where the bottom's a triangle, or a hexagonal prism where the bottom's a hexagon. You can have any sort of prism you want as long as the top and the bottom are the same, okay? All right, so I do have a prism to show you that's, one of those shapes. So this is a prism, okay? The heights, this is a really tall prism, okay? If you consider this the base, this red part is the base, and then this is the top, and those are the same. You could also put it on your side like this and have it like be a shorter prism, and this would be the base, and this would be the base, okay? The thing that, when you find surface area, this is not hard, okay? Because every single shape in this prism, you can look at this one too, every single shape is a rectangle, and finding the area of a rectangle is not hard, right? To find the area of a rectangle, you just do base times height. Okay, the thing you have to remember is that there are 6 rectangles for every prism. So every time I ask you to find the surface area, you have to find 6 rectangles. The top and the bottom are the same. These 2 sides are the same, and these 2 sides are the same. Okay, so you're basically going to find 6 rectangles and add them up. So top, bottom are the same, sides are the same, and then these 2 are the same. Okay, all right. So you probably learned how to draw these at some point, but I'm going to show you also. So today we're doing, my board is not staying on today, a rectangular prism. Okay. So to draw a rectangular prism, it is actually helpful if you have like grids because it makes it so you can draw them a little perfectly. But if you don't have graph paper, you can draw freehand. It's not a problem. Okay. So to draw the base, you want to go out, and I'm going to go out like 4 boxes, although that doesn't necessarily represent 4. And then this is the tricky part. To make it three-dimensional, you have to make this slanted. And whatever slope you use, so I did over 2 up 2, you have to do the same exact thing on this side. Boy. Okay. And if you have a ruler to make it perfectly straight, it does help. All right, and then you just connect these, and sometimes we dot those because those are actually lines you can't see. Okay, and then when you want to make a prism, you have to make the heights exactly the same. So just count. So like, let's say we wanted to make this have a height of 2. So you go up 2, up 2, up 2, and up 2. So from each corner, you go up the same amount, okay? And then you just connect those. So you draw straight line, connect, okay, straight line, and connect. Okay, and then you have your rectangular prism, okay? All right, so let's just use, for these dimensions, let's just use that this is 4 inches, yet let's use that this is 2 inches, and let's use that this is 3 inches. Okay, so again, finding the area of a rectangle is not the part that's hard, it's just being able to see all the sides, okay? So to find the surface area, okay, let's do the top and the bottom first. The top and the bottom are always the same or it wouldn't be a prism. So the bottom right here is 4 inches by 3 inches. So the bottom has a surface area of 12, 3 times 4. The top also has a surface area of 12. So the top and the bottom, there are 2 that are 12, okay? Then what you want to do is you want to do the 2 sides. So like this side and this side. And those are each have a surface area of 6 because it's 2 times 3. Hold on, let me get my other colors. So this side right here is 6 and this side right here is 6. So the sides, there's 2 of them that are exactly the same. are going to be 2 times 6. Okay. All right. And then there's one more. Okay. I'll do those in green. There's the front and the back. Okay. That's this part right here. So this is the front and this is the matching back. So like on my clamp box, okay, this was the top and the bottom. These I called the sides, but we haven't done the front or the back yet. Okay, so this is 2 inches, but all the green lines are 2 inches. So this is also 2 inches. So the front is 2 by 4, which is 8. And of course, that's the same as the back. So this is 2 times 8. Okay, so basically this rectangle has an area of 6. This rectangle has an area of 8, and the bottom and the top have an area of 12. I know the picture gets like kind of busy and it's hard to see, so you just make sure you follow each one a little separately. So this one's 24 plus 12 plus 16, and then you just simply add those up. So these add up to 28, and then 28 plus 24 is 52, and this is inches squared. Okay, all right, let's do another one. Okay. All right, this one, since probably a lot of you don't have graph paper, I'm going to draw this one over here, okay? If you, like I said, if you have a ruler, it does help, okay? But basically, you just want to draw straight line, okay? And then whatever slope you use here, just try to match the slope there. So this should be exactly the same, and then just connect. Oh, that line usually I make dotted, sorry. All right, and feel free to adjust it. You can be like, oh, you know, this one looks a little more slanty, and just fix it. Okay. All right, then you're gonna go from here, you have to go up. And whatever amount you go up, you have to go up the same exact amount, and same exact amount. And that's when using a ruler would be handy, because you could measure it, like go up 3 inches or something, okay? Go over straight, okay? Connect the slants, go over straight. Sometimes people dot this one because it is behind. Okay. Okay. And I actually did draw these for you on your homework, so you don't actually have to draw them, but it would have been part of the class if we had been together with me teaching you how to draw those. Okay. And then again, you can fix it a little bit if you need to. I'm going to fix this a little bit. So for this one, let me give you some dimensions. I'm going to call this 10. Okay, I'm going to call this 6. And I'm going to call this 4. Okay, so it's a 10 by 6 by 4. Okay, and remember there's 6 surfaces, top, bottom, 2 sides, front, back. Okay, all right, so let's do, just to be consistent, I'm going to always do the top and bottom first. So the bottom is this part right here. It's a 10 by 6, so that's 60. And the top is also going to be 60. So the top and bottom are both 60. So we have 2 that are 60. Okay. All right, when I say sides, I mean these 2 sides. And those are 6 by 4. So that's 24 right here. And then this one's also 24. So we have 2 that are 24. Okay. All right, and then, of course, there's still the front and the back. Okay. All right, the front and the back is this. This is the front, and this is the back. So this is 10, and then you have to know how tall this is, but the heights are all the same. So this is a 10 by 4, so the front is 40, and the back is 40. So this is 2 40s. Okay. So every single rectangle will have a matching one, but they're usually all going to be different, okay? All right, so then this is 120 plus 48 plus 80. I'm going to add these 2 together first. 120 plus 80 is 200, so we have 248 inches squared. Okay, all right. And by the way, you might notice that I'm not drawing nets for this. Drawing nets for these is actually really hard. It makes it harder, not easier, so that's kind of why we're not doing that. Okay, I only have one more problem to show you. Okay, this you probably know is called a cube, you know, kind of like a Rubik's Cube or whatever. The difference with a cube is it's a little easier because every single side is the same. So we still have 6 sides, but if you know the area of, say, this blue one, it's going to be the same as this one, same as this one, same as this one, same as this one. So it's a lot easier because there's not like 3 different areas, there's only one area, okay? And it's called a cube, okay? So when you draw a cube, hold on. So if I tell you it's a cube, that means that every side's the same. So a cube has all sides the same length. Okay. So when you draw a cube, let's say I went like over 3, then I'd have to guess 3. I'm just guessing that that's 3. Okay. And then you'd want to go up the same amount. 2, 3. 1, 2, 3. Okay. And then you'd connect. Okay, so we have our cube, and all I have to do if it's a cube is give you one measurement. So I could say that this is 5 feet. Okay. If that's 5 feet, then this is 5 feet, and this is 5 feet, everything's 5 feet. So all you have to do is find the area of one side. So that would be, that one side would be 25, and there's 6 of them. So you do 6 times 25. So the surface area would be 150 feet squared. Isn't that nice? Okay. So cubes are much easier. You'll get them every once in a while, but most of your problems will be this way because they're harder. All right. So again, you can always email me if you have a question. I can help you individually. I can help you over email. I can also help you over Zoom. So just let me know. Okay. Bye, guys.